The Microchip 8-bit PIC devices use different configurations to handle interrupts. Most baseline devices do not implement interrupts at all. The enhanced baseline and mid-range devices have a single fixed location interrupt vector to handle all possible interrupt sources. Most PIC18 devices have two fixed location interrupt vectors. And finally, some PIC18 devices have relocatable interrupt vector tables. Check your datasheet to find how interrupts are configured on your device. The devices allow for backwards compatibility. Those PIC18 devices with the vectored interrupt controller can run in a legacy mode, in which they revert to using dual vectors. And regular PIC18 devices can run in a mid-range compatibility mode, in which they revert to a single vector. This webinar looks at interrupt function syntax and code to control interrupts for each interrupt configuration. To use interrupts for the enhanced baseline and mid-range devices, write one interrupt function for all the code that should be executed after an interrupt has been triggered. The interrupt function can use any valid C identifier as its name. The function should take no parameters and return no value. You can use either the interrupt keyword or the _ interrupt specifier with empty brackets. This function will handle all interrupts, so your code should only execute after checking for the interrupt source. You should check both the peripheral's interrupt flag and interrupt enable, since an interrupt flag can be asserted even if you are not using that peripheral. The interrupt code might need to clear the interrupt flag once that source has been processed. Never re-enable the interrupts inside the interrupt function. That will be and must be done by the device when the interrupt returns. To process other interrupt sources, add other tests for the appropriate interrupt bits. In mainline code, and when required, enable interrupts for your peripherals and set the global interrupt enable bit. The PIC18 devices that do not have the vectored interrupt controller module use two interrupt vectors, one for interrupt sources with a low priority, the other for high priority interrupts. For these devices, determine the priorities to assign to each of your interrupt sources. Then write one interrupt function for each priority you are using, so you will have at most two interrupt functions. The function should take no parameters and return no value. You can use the interrupt keyword and the low priority or high priority keywords. Or you can use the _ interrupt specifier with the priority specified as an argument. Each function will handle all the interrupt sources matching its priority, so the interrupt code needs to check for the interrupt source as we saw in the previous slide. In mainline code, you should assign priorities to the peripherals you are using, enable the peripheral interrupts, and when ready, set the global interrupt enable bits, 2 in this example since both priorities have been used. If you are not using either or both interrupts, it is a good idea to safely handle interrupts that are triggered unexpectedly. Consider implementing both interrupt functions, or use the --undef_ints option, so that uninitialized vectors can be programmed with code to execute a reset or software breakpoint if that interrupt should occur. This option can be specified as an additional linker option if you are using MPLAB X IDE. The PIC18 devices which have the vectored interrupt controller module but which are running in legacy mode still use two interrupt vectors for high and low priority sources. Assign priorities and write the interrupt functions as we saw in the previous slide. For these devices, you can specify no parameters and check for the interrupt source in the function body as we have seen previously. Alternatively, you can specify a single char parameter and use this to determine the interrupt source by comparing it with predefined interrupt source macros. Look for the chipinfo HTML file located in your compiler's docs directory for the macro names associated with each interrupt source. Mainline code needs to assign priorities and enable the peripheral and global interrupt enable bits, as we saw earlier, and the --undef_ins option can again be used to program uninitialized interrupt vectors. The PIC18 devices which have the vectored interrupt controller module and which are using interrupt vector tables can execute a dedicated interrupt function for each interrupt source. Determine the priorities to assign to each interrupt source you plan to use. Then, typically, you will write one interrupt function for each source. You must use the _interrupt specifier with the interrupt function. Indicate the interrupt source by using the IRQ argument and a predefined symbol corresponding to the interrupt number. The interrupt source symbols can also be found in the chip info files. Specify the priority of the interrupt using the appropriate keyword as an argument to the _interrupt specifier. Since this function does not need code to determine the interrupt source, it will execute promptly. The mainline code requirements are the same as for legacy mode devices, and you can use the --undef_ins option to specify uninitialized vectors. Interrupt functions for PIC18 devices using vectored interrupts can handle multiple interrupt sources if you prefer. To do this, specify a comma-separated list of source symbols to the IRQ argument in the _interrupt specifier. Inside the function, use the parameter to determine the source of the interrupt if necessary. A default interrupt function can be written that will be assigned to any interrupt vector in the table that does not have an interrupt function assigned to it. Such functions are created by using the special source symbol default in the IRQ argument. All the interrupt functions you define for devices using vector tables will, by default, be located in a vector table with a base address of 8. The function addresses in the vector tables cannot be changed at runtime. However, you can define alternate or additional tables and swap to the required table during program execution by setting the IVT base registers. To populate a specific table, define interrupt functions that use the base argument to the _interrupt specifier. The address you specify is just the base address. The vector used by a function will be located at this base address plus an offset determined by the interrupt source the function specifies. And thus, all functions in the same table should use the same base address. If required, you can write more than one interrupt function for the same interrupt source and use a different base address with each so that different interrupt functions can be executed at different times in the program. At runtime, you can specify which table is active by writing to the IVT base registers. You must do this while interrupts are disabled. The address should match one of the base addresses you have specified with your functions, and this address must be a multiple of 2. Ensure that you have left enough room for all the entries in your vector table. However, the compiler will emit an error if it detects overlapping vectors. You can have the IVT base registers initialized by the runtime startup code, if you prefer, by specifying the desired table base address to the IVT sub-option to the --runtime option. The active vector table can still be selected later during program execution by writing the IVT base registers. If you would like the same interrupt function to be assigned to more than one table, specify a comma-separated list of addresses in the base argument. The example shown programs the function into the default table and another table with a base address of 200 hex. If a device with the vectored interrupt controller module is operating in legacy mode, vector tables are not used and, as we have seen, the device uses the conventional dual interrupt vector scheme. But even in this mode, you can still define alternate or additional sets of the two interrupt functions and have these become active by changing the IVT base registers. To populate a specific vector location in legacy mode, you must use the _interrupt specifier. Do not use the IRQ argument. Instead, use the appropriate priority specifier. Use the base argument to specify one or more vector set locations for that interrupt function. The --undefints and IVT sub option can both be utilized in this mode, as described earlier.